Okay, today I want to talk about asset allocation or portfolio selection, whichever one you want to call it. The rule, if you're a portfolio manager, is you want to diversify. And can you spell diversify? The question is, how do you diversify? Markowitz in 1952 set the foundation for how we still do this today. I want to go through the steps that would be necessary here. So, step number one would find historical prices. And of course, I will give you historical prices in an exam setting. In our world, we just have a stock fund and a bond fund. So we have, thousands of stocks, but they're all wrapped up into one stock fund, thousands of bonds, all wrapped up into one bond fund. We have a risk-free asset, but we don't have that yet. So for right now, ignore the risk-free asset. Step number two, using the historical prices, you need to calculate the expected return and the covariance matrix. Now, I want to make sure we get our terminology right here. When I say covariance matrix, that means you're calculating expected, you're calculating the standard deviation for the stock fund and the standard deviation for the bond fund, and you're also calculating the correlation between the two. Alright, now that you have that, let's see how we could invest. So what are our possibilities? Well, the bond fund has an expected return of 7, so I'm just going to eyeball this. So the bond fund is right about there. The stock fund has expected return of 15 and standard deviation of 20. So the stock fund is going to be right about there. So I could be 100% in stocks, 100% in bonds. Now, the blue line is drawn based on the correlation between the two assets. So I could have a line that just connects stock and bond, like the pink line. That if correlation was equal to 1, then I could invest anywhere along that pink line, which would be 100% in stocks, 90% in stocks, 50-50, 100% in bonds, anything like that. If the correlation were -1, it would look something like that. So those would be my possibilities. But my possibilities are governed by the correlation, which is 0.3, which gives me this curved line. Okay. The next question, this will be one of a practical issue, but for now we'll say you can short stocks. So if this is 100% stock, the little red dot, anything above that means I'm more than 100% stock. And the way I become more than 100% stock is I short bonds. Same thing down here. Anything below this point, you're more than 100% bonds. So if you're 120% bonds, you're negative 20% stocks, which just means you shorted the stocks. So that's our blue line, the possibilities that we have. The next thing we need to do is say that we have a risk-free asset. So next thing we need to do is observe the T-bill. We'll say the T-bill is risk-free. We can argue about that later. Observe the risk-free asset, which is in this case gives a return of 3%. Step number 4, we want to find the optimal risky portfolio. You can do this with 2 stocks in a calculator. When you start to get 3 stocks or 4 stocks, you really need an optimization routine in Excel or something like that. But just for now, let's just eyeball things. So you could have the combination on the pink line. So when I say optimal risky portfolio, let me make sure we're clear what I'm talking about. That means I'm putting some amount of money in stocks, some amount of my money in the bond fund. That total, that 100% that I have invested, that is what I'll call the optimal risky portfolio, maybe call it the model portfolio, whatever. So we have a choice now. We can invest all in T-bills and get a 3% return, or we can invest all in this optimal risky portfolio and get whatever return that is. So would I want to be on this pink line? Well, look at the possibilities. Which one's better, the pink line or the green line? If I take a 10%, I'm willing and able to bear 10% standard deviation, I'll get, well, it's about 3% return. Or from the green line, I can get just under a 10% return. So what I want to do is I want to draw the steepest possible capital allocation line. That's what it's called, the capital allocation line. Let me erase some stuff here. Okay, so that means I want to be on this green line. In this point right here, call this a tangency portfolio, or the optimal risky portfolio. So, hang on just a second. Okay. So as a portfolio manager, I've identified this optimal risky portfolio. You can invest either in it, which is a combination of stock and bond, or the T-bill. Now, imagine I have a client that comes in. So these are the first 4 steps. I've found basically this green line right here. So now I have a client that comes in. The client, based on discussions in the the investment policy statement that we've come up with, we say the client needs a return of 8%. So, somewhere right in here, the client needs this return of 8%. The question now is, how much should the client put in the stock fund, the bond fund, the risk-free asset, which I'll call the T-bill? So what percentages, you have to tell me what those percentages will be. That, of course, will add up to 100%. The other way we could look at this, a different client comes in, and we've determined what risk this client is willing and able to bear, and we've quantified that and say that's a 10% standard deviation. So based on that, what's the way of the stock, way of the bond, way of the T-bill, which of course will add to 100%, that this client how should he invest? Diversify. Exactly how should this client diversify? The other way to look at this, and the final way, is we will estimate the client's level of risk aversion. Given the client's level of risk aversion, what's the way of stock, way of the bond, way of the T-bill that should be in the client's portfolio. Okay, so let's think about a couple of what I'll call implementation issues. Implementation issue number 1. Do we have short sales? We will do this for the most part. We're a 2 asset portfolio, but 2 risky assets and adding the risk-free asset. It gets much more complicated, and you need an optimization routine if we get beyond that. But now let's think about it in the simplest terms here. So short sales, can we short the stock? Can we short the bond? If not, we have a constrained optimization rather than unconstrained. But here's a real problem. And think about what you're trying to do as a portfolio manager. You're trying to come up with a better optimal risky portfolio, because you don't know what clients are coming in. You got, this guy with expected return, this guy with his level of risk, this guy with his level of risk aversion. You don't know who's coming through that door, but what you have determined is the weights for the optimal risky portfolio. You have observed the risk-free rate at 3%, and then anybody, once you have this set, anybody that comes in the door, you can tell them their asset allocation. You can select that optimal portfolio for them. Okay, but what we've done, and Markowitz, by the way, noted this in his paper, he said you need the expected returns, you need the expected covariance matrix, but we've used historical prices. We can't say that historical prices is going to give me the expected returns and covariance matrix. So what we've really found here is not the optimal risky portfolio going forward, and that's why I want to know. If I'm your client, I want to know what the optimal risky portfolio for me will be over the next year, 2 years, 5 years, 10 years. What we've found is what the optimal risky portfolio was over whatever time period we used for these historical prices. So the big problem of actual implementation of Markowitz's theory is finding the correct inputs. If your inputs are different than mine, then you're going to come up with different weights for the optimal risky portfolio and different advice for the client. And if you give better advice for the client than I do, you take my business. So we're going to do the following different approaches to kind of try to come up with better inputs. The first is a single index model. The second is the Black-Litterman model. And once again, the whole goal here is better inputs. Can you find those better inputs? Alright, so let me remind you of a couple things here. Let me pause. Alright, so just let me remind you some things. Maybe I'm not reminding you, maybe you're seeing it for the first time. But nonetheless, the expected return, and by the way, this is the expectations operator. E brackets, whatever's in brackets, the expected value of that. Sometimes I'll just drop that out just for notational ease and just say the return on the portfolio is equal to, and you should know from the context, are we talking about past returns or expectations of the future? But it's going to be valid, this calculation is valid either way. The weight of asset A times the return of asset A plus the weight of asset B times the return of asset B plus the weight of asset C times the return of asset C. You know, it keeps going on out forever, but we just have a 2-asset portfolio, so that's the expected return. The variance, or the risk, is going to be very similar. We take the weight of A squared times the variance plus the weight of B squared times the variance. So in other words, the expected return is the weighted average of the returns of the individual assets. The risk, the return is the weighted average, the risk is the weighted average of the risk of the individual assets. But there's one thing that I'm leaving out, and that's the following. You want to know how those assets move together. So this is the risk contribution of A, the risk contribution of B, but how do those assets move together? That's what we have here. This correlation is a big number. Correlation can be from -1 to +1. If it's +1, look at the math here. If it's +1, I don't get very much risk reduction. I'm adding risk. Well, negative, if it's negative, I'm getting risk reduction, right? So the lower this number is, the less the risk of the portfolio is going to be. Right? Where does this number come from? I also want you to remember, you've calculated covariance. So the correlation of A and B is equal to the covariance of A and B divided by their standard deviations. Now this is just not randomly assigned. I want you to know where this comes from and the reason for it. So if I do this calculation and I find that the covariance between these two assets was 0.003, is that good or bad? What exactly does that mean? How can I interpret that? I need an intuitive feel for it. Well, I know it's positive, so I know the assets move together, but I don't know the magnitude. Do they move together perfectly or just a little bit? So I need to scale this. So I divide that by the 2 standard deviations, and that will force correlation to be between 1 and -1, so I can have a scale and have a sense. When you tell me the correlation, you know, the correlation we had before was 0.3, you tell me that, I have a sense of how those two stocks move together, When you tell me the covariance is some number, I don't have a sense of what that means, so that's the purpose of correlation. Okay, so in class we'll have you do some actual calculations going through this stuff, but the big thing before we move forward is I want you to have a good intuition, a good understanding of exactly what we're trying to do, and know that the theory is perfect, it works great, except for we don't know what the expected returns in the covariance matrix will be. We only know what it was. And the last thing, I forgot to C right there, so I'll put that in and see you Wednesday.